robotics show. And it was interesting to see that there they had many humanoid robots on a wheeled-based platform. And it was also very interesting to see that instead of individual robots making fancy moves, they now have the robots working together in a production line. There always has been the drive to make a better tool, although now physical AI drives the explosion of new robotic use cases. Physical AI is the integration of artificial intelligence into autonomous systems. By training AI models and leveraging reinforcement learning, robots can safely and efficiently learn skills through trial and error in a virtual environment before they are deployed in the real world. When we have the ChatGPT moment for humanoid robots, then the question becomes, do you really still need a self-driving car? The humanoid robot can drive you around. You see that here in the picture of some startup that already does that. Maybe more important, it can operate older industrial equipment, similar to how a human would do that. In the bottom left, you see a humanoid robot delivery driver. And in the middle, a humanoid robot that can pick every day the crop that is ripe and or has a specific size. It could do that during the night. We talk about making a physical replica after the product is designed and produced in a digital factory. This is completely opposite to making a digital twin in a virtual environment. This has huge social implications. When ChatGPT came out and people did see how it would make images and art and music and text, some were saying AI is currently automating the wrong kind of jobs. I want AI to do the mundane jobs instead of art and writing, and not the other way around. Well, the humanoid robot that can do it all will solve this. It will give us choice. We can dance with our children, spend time with our parents, and walk the dog, while the AI does all the work. We can choose to have a human or a robot cut our hair. The bottom row images show robots learn to walk in an accelerated training environment, where thousands of robots can be deployed on accelerated time, without the need for everyone to have changed the battery or even consider power. Still, systems have to be verified in the real world in real time. Okay, now back to now. Here's an overview of the applications where autonomous robots are used today. You see different categories. Of course, we talked already about warehouses, but now you see in medical delivery robots or service robots, and also the category where you have outside delivery robots. Smart retail, where robots do inventory management and picking and sorting. And also commercial landscaping, where you have autonomous lawnmowers, and of course security, where we have surveillance. So what do all these robots have in common? We already talked about on the power side, they have a battery, they have motors to drive wheels, and they have a charging solution, either external or internal, and many safety, power safety things like e-fuses. And so we're going to look at some of these systems, and they have, of course, also many different sensors to drive around, and that's what we will discuss in part 2 of this series. So we'll focus on the autonomous mobile manipulator, which is in fact the cobot and a mobile robot, the quadruped and the humanoids. And these systems will give flexibility for production sites to operate on loading and unloading a CNC machine or some other equipment. And this collaborative work with humans will get more and more attention, and also requires these systems to be very safe around people. So for these type of systems, onsemi has many different products. On the left side, we see our power products, which range from gate drivers, MOSFETs, of course, silicon carbide solutions, LDOs, DC-DC, our eFuse solutions. So onsemi has created a system solution demonstrator for a mobile robot, which you see here on the left. And we also recently created a sensor hand, which will become an arm and grow into a robot platform. And then both these systems will address the needs in these type of applications for motor, joint actuator, or motor control, lighting systems, power systems, etc. So for the autonomous mobile robot, we have an overview of all the different subsystems in this robot. We defined 7 subsystems, so the power distribution, the motor drive, wired communication, lithium-ion battery charging, LED lighting. Then there's the processor. We have power solutions to power the processor, but the processor itself, in this case, is an NVIDIA Orin system. So let's first look at the power distribution. Here you see the power distribution subsystem that we have in the robot. This is the guide for us to include it in the system solution guide. But of course, there can be changes to this. We see some applications where there's no regulation to the motors, where it's just directly from the battery. You do have several different voltage rails. So we create these here with one of our products, which we want to go over. And then I also like to highlight in this system the eFuse that you see here in the middle that can protect the system and also help with restarting it in a safe mode after it has been triggered. Here's an overview of the efficiency for one of our buck regulators. In this case, it creates 3 power levels. Three of these systems are used for 24 volt, 19 volt, and 12 volts for the different solutions in our robot. The features for this part are listed here for up to 66 volts for in 3 different flavors, 6 amp, 8 amp, and 10 amps. And this has protections in it over temperature, over current, and many others. And so this is what we use to create the different voltage rails in the robot. And as I mentioned, also we have the eFuse that I like to put some extra attention on here. This is a product. In general, you see that in the robotic space, first people went for the functionality, and now they want to make products that need to be safe in all different scenarios. And this is one of those products that enable you to do that. This is a 4-channel eFuse that can be used combined with the 4 channels to have a 10 amp, 60 volt, 10 amp solution maximum. You can split to make 2 5 amp channels, or use all the 4 channels separately and have 2.5 amps per channel, a 60 volts solution for eFuse, where you have over temperature and current protection. And this can be with a remote computer enabled and disabled, and also have soft start. So secondly, let's look at the motor drive. So for motors in general, wheels, motors, and gears, from a warehouse robot where you have 2 wheels driving the robot, up to the right side where you have a humanoid which has about 30 motors in there. The motors in the humanoid and in these more complicated systems are one of the cost driving factors. They're called joint actuators and have, in addition to the motor drive, communication interfaces and also sensors to control the motor in a safe way. These motors come with gears, higher gears ratios for cobalt arms to get higher torque. But then for humanoids, specifically if they have to jump or do weird actions, you want speed. So you have to trade off speed for torque. And there you see on those specific motors in the legs, lower gear ratios, and so different setups. And in the arms, you might have a different type of motor to enable to do more finer work. So the subsystem for our mobile robot, which drives 4 wheels, we have for each motor on each wheel a 3-phase motor drive, which uses our trench 10 MOSFETs and a 3-phase gate driver. And so you see that configuration here. We'll go to look at those two. I just want to point out here as well that in this subsystem, bottom left, we have a communication interface where we use our 10-base T1S solution, which is a twisted pair IP-based communication protocol to control, to direct this motor for its functions. So here's an overview of all our Trench 10, our latest trench technology MOSFETs for low voltage. You can see the RDS-ons for these, and in the middle one here, we also have power package solutions. Of course, the standard ones, you see the top, and then there's more latest designs where you have dual cool technology in a 5x6 and also a top cool technology in a TC pack solution. So we have all these different solutions available depending on the thermal heat dissipation and the needs of your system. Then the 3-phase gate driver we have in our mobile robot. There's some information here. This is going up to 60 volt and constant current drive for the FETs. And it's a very good solution for power tools, for industrial actuators and cobalts, as well as the robot system that we use this in. It's in a QFN 4x4 package. Good. Let's look at the communication. I already mentioned that we use our 10-base T1S solution. It uses the same twisted pair as a CAN solution, and it's IP based, but you don't need hubs and switches. You can just have stubs hanging off the bus with up to 8 nodes specified by the standard, and it keeps the whole system in an IP based solution. And we have that in our robotic solution, as well as it's used in zonal architecture for automotive applications. NCN 26010 has the Mac included, and there's also a version without the Mac that you see here. Good. Then the battery system, battery charging. So we have a block diagram and a system solution guide for a silicon carbide based 3 kilowatt charger. This uses Elite SiC for the diode bridge rectifier, get higher efficiencies, and the part numbers are listed here for the different items that we use. So it's a totem pole PFC controller, and as well at the secondary side we use an LLC solution, and you see that here as well. Then lighting. So I mentioned already earlier, lighting becomes more important as these robot systems work together with humans in the same space, as you can see in the top left here. And to indicate what these robots are doing, they use lights either to project on the ground or on the device itself, like almost like a car. If you see white light, you know it's driving towards you. If you see red light, it drives away. There's some mode lighting for battery charging, or another mode that it's active or safe to approach. And here we see forklift trucks, autonomous mobile forklift trucks that have a laser light projected on the floor, so that if people are around the corner or cannot see the robot, they see the light then first and know that it's approaching. So for the lighting solutions, there is a 12-channel linear current PWM control solution that we use for the corner lights in our mobile platform that have the white light, the red light, and turn sign indicator. So the system is shown here, and the 12-channel LED driver is the NCV7685 shown here. And then, as mentioned, we have a mode light, blue for charging, green for ready, etc., which we do with a matrix display and some of our other power solutions. Then we have PMIX for power over coaxial. You can think about camera systems that use that. We just released a selection guide for LDOs, and you can see here in the selection guide we have a very quick overview for all the different LDOs we have, where you can select on the different characteristics like the power supply rejected noise level, or the current IQ, and we also have these in the most popular types of packages. So there's different package solutions for that. So definitely something to look out for the selection guide that is available now. Okay, with that, I will open it up for questions. Most important is onsemi.com and finding this robotic system selection guide, and then reaching out if there's still questions for your products. And I hope this was informative. Thank you so much.
All right. Well, thank you, Theo, for that really interesting presentation. The explosive growth in the capabilities and the uses of AMRs has been so fascinating to watch the last couple of years, and will continue to be for many more years to come. So we've already got several interesting questions, but I want to let our audience know that there's still time to submit those questions. Theo, you ready to answer?
Yes. Yes, I am.
All right. Well, the first one's kind of a fun one here. Is what are the most unusual use cases for AMRs that you have seen?
Yeah, I have. You hear a lot of different versions